Hi students, welcome back to myclass.com. Our new subject we are starting, statistics. The video is starting on descriptive statistics. Descriptive statistics is mainly two type of descriptive statistics. We are discussing the numerical methods of descriptive statistics. Let's start. So what are descriptive statistics? Descriptive statistics are brief informational coefficients that summarize a given data set, which can be either a representation of the entire population or a sample of population. If we are taking a whole population, like in the normal population in India, we are taking whole the population all around the India, then we can call it as it is the population for our statistics. But we are taking only some sample from that population or sample from that survey around our panchayat or our municipality, then we can call it as it is sample. So we want to summarize a given data set or a given data set of population or a sample of population, we are following the descriptive statistics method. So these statistics are broken into two: measures of central tendency and measures of variability. Measures of central tendency include, we all know that it is easy also, mean, median, mode, percentile and quartile. But the measures of variabilities are range, interquartile range, quartile deviation, mean deviation, variance, standard deviation and coefficient of variation. Like that. So here we are just assume that this is a sample of data. So in this sample of data, measures of central tendency is concentrated on the central value. We are calculating a typical value, that is we can say it as an average, or it is that this is the central value for that particular data set. But the measures of variability is little different. We are discussing in the later videos. Let's start with the measures of central tendency. So what is central tendency? Measures of central tendency focused on the average or middle values of data set, whereas measures of variability focus on the dispersion of data. Actually, when we are considering a data set, the measures of central tendency is concentrated on the central value, but the measures of variability is concentrated on how this value is dispersed in whole the data set. That is the difference between the central tendency and the variability measures. So these two measures use graph, tables and general discussions to help people to understand the meaning of the analyzed data. When we are going through the data analysis or data, so we are always going through the descriptive statistics week. So the measures of central tendency describe the central position of a distribution for a data set. A person analyzes the frequency of each data point in the distribution and describe it using mean, median, mode, etc., which measures the most common pattern of the analyzed data set. So for calculating measures of central tendency, we are calculating mean, median, mode, percentile and quartile. Then measures of variability. What is measures of variability? Or the measures of spread. We can call it as measures of spread also. Aids in analyzing how dispersed the distribution is for a set of data. For example, while the measures of central tendency may give a person the average of data set, it does not describe how data is distributed within the set. How all values are distributed within a data set. Measures of central variability is not concentrating on that. Measures of central variability only concentrating on the average of data set. So while the average of data may be 65, if average of a data set is 65 out of 100, there can still be. Then also there is a, if it is based on a mark list, it is sure that maybe some student had scored 1 mark or some other student scored the full mark. Okay. So measures of variability is helping to find the spread of values in a particular data set. So measures of variability helps to communicate this by describing the shape and spread of a data set. For this we are calculating range, interquartile range, variance, standard deviation, etc. So let's consider this following set: 5, 19, 24, 62, 91 and 100. So the range of that data set is 95. How we are calculating the range? Highest value. The highest value of this data set is 100 minus the lowest value. So 95. So when we are getting a range like 95, we can easily assume that there should be a higher value like 95 above and also very little value like 5, because out of 100 we get the range as 95. So that is one of the example of calculating measures of variability. Now we are concentrating on measures of central tendency in this video. So what is our first central tendency calculation? Mean. Mean means actually the average. So the arithmetic mean is the sum of all observation divided by number of observations. So the formula is sum of observation divided by total number of observation. So if we have n observation or maybe 10 observation, we are adding all the observation and divided by the number of items in the data set. That is the calculation of the arithmetic mean. So let's assume that there is an 8 student mark in the cluster. They scored like that 10 plus 19 plus 12 plus 21 plus 18 plus 20 plus 11 plus 19. So all the value we are adding then divided by 8. That is the calculation for arithmetic mean. So here we are adding 10 plus 19 plus 12 plus 21 plus 18 plus 20 plus 11. So the total number of after the summation, the result is 111 divided by 8. 111 divided by 8 is the values 13.875. So this is the arithmetic mean for this the above data set. So next is it is the normal data set. If the data set is with the distribution with frequency distribution, then the equation is little different. Arithmetic mean formula for frequency distribution. The formula for the arithmetic mean for the frequency distribution can be derived by summing up the product of each variable and its frequency, and then the result is divided by the sum of frequencies. Let's assume that this is like that. If 5 marks is scored by 3 students, 10 marks is scored by 2 students, 12 marks is scored by 10 students, like that. So we want to find the product first. We are calculating the product first and then we are summing this value. Like that, the frequency distribution calculation of arithmetic mean is going on. So the equation is the normal arithmetic mean is summation of xi divided by n. But for a frequency distribution, we are first finding the product fi into xi, then divided by fi. Let's assume that. So this is the one of the example for the frequency distribution with the class interval. Here we are getting only the class interval. So in this class, so this is our class interval. Okay. So the class intervals are going like 0 to 10. So when the question is like with the class distribution, we want to, so we are not getting so we are only have the class values, class interval values. So we want to calculate the mid value of this calculation, that is our x. So we want to find the mid value, that is 0 plus 10 by 2. So 5 is the mid value, 10 plus 25 by 2, so 15 is the mid value. Here 25 is the mid value, 35. 45 and 55. Now only we will get the x value. Then the x values, the frequency for all the x values also we had given. So that is our frequency. So this is our xi, this is our fi, 7, 14, 28. So this is from our question, 26, 16 and 9. Now we want to calculate fi into xi. Okay. So 5 into 7, 35. 14 into 15, 210. Now I am calculating this by using calculator, 495. Okay. So our total, we want to calculate this total of fi also, total of fi into xi also. So total of fi is 7 plus 14 plus 28 plus 26 plus 16 plus 9. So here all calculation, maybe this is for a mark distribution, 100 students are there. So 100 is the total. So we have already calculated the fi into xi. So we want to sum up all this value also. So 35 plus 210 plus 700 plus 910 plus 720 plus 495. So our total is 3070. Now how we are calculating the arithmetic mean? Summation of fi into xi divided by fi. 3070 divided by 100, that is 30.70. So this is the way we are calculating the arithmetic means for frequency distribution. Now we are calculating the median. The next median is simply the middle value of the data set. In order to calculate the median, all values in the data need to be ordered. First, we want to order the data set. Okay, from highest to lowest or lowest to highest. In any way we want to arrange the data set. If there are an odd number of values of that data set, it is easy to calculate. Okay, so even it is like that. See, 10, 12, 13, 14 and 15. This like, let's assume that this is our data set. So this is our n is equal to 5. This is an odd number. Now it is easy that we are calculating the middle value. So we are here discarding the 2 and here discarding the 2. That middle value is 13. So 13 is the median of this data set. If it is an odd number, if it is an even number, then let's assume that there is a 9 also there. So then the n is 6. Now we want to calculate like 12 plus 13 divided by 2. That is the median of this data set, because it has an even number of values. Okay, so this is the equation. If n is an odd, median is size of n plus 1 by 2th observation. If n is an even, size of n by 2th observation plus n by 2 plus 1th observation divided by 2. Let's go with an example. So this is our data set. This is already arranged in an increasing order. Okay, so it's containing 12, I think 12 numbers are there. Is it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it is an even number. Then how we are calculating size of, we are n by 2th. N by 2th observation means 12 by 2th observation, that is 6th observation. Also n by 2 plus 1, that is 6 plus 1, 7th observation divided by 2. So which one is the 6th observation? 1, 2, 3, 4, 5, 6. 3490 plus 3520 divided by 2. So this median of this data set is 3505. If let's assume that this value is not there, that is n equal to 11. So this is an odd number. Then now we are calculating n plus 1 by 2th observation. N is 11. 11 plus 1 by 2. That is 12 by 2. 6th observation. Which one is the 6th observation? 1, 2, 3, 4, 5, 6. So this is the median for the data set with the odd number. Okay. Another central tendency variable is mode. The mode is the most commonly occurring number in the data set. The mode is the best used when you want to indicate the most common response. If most of the students scored 52 marks, then we can say that 52 is the mode of that data set. Okay. For a class interval values like a frequency values, there is another equation for calculating mode, that is n1 plus d1 by d1 plus d2 into I. So these all symbols are. So let's go with an example to calculate a mode by using this formula. This all values are we can easily identify. Let's go with an example. If the data set containing if it is a simple data set with lots of values, some values are repeating, then very easy to calculate the mode, that is 10. In this data set, 10 is repeating 3 times. The mode of this data set is 10. Otherwise, if the data is like a class interval, if the data set is like this, then we are going with this equation. So what is this equation? So first we want to calculate the model class. So what is model class? The one with the highest frequency data interval. Here the data intervals are 0 to 10, 10 to 20, 20 to 30, 30 to 40 and 40 to 50. Here the 10 is the model class. 10 is the highest frequency. So the model class for this data set is 20 to 30. Okay, so first we want to calculate the model class. The model classes for this data set is 20 to 30. Now what is L1? Lower limit of the set model classes, that is lower limit. So the lower limit is 20. So L1, we have got L1. Now D1, what is D1? D1 is FM minus F1. So what is FM? Model class frequency. So model class is 20, 30. So frequency of the model class is 10. So 10 minus what is F1? Frequency of the class which precedes the model class, which precedes in front of the model class, which class is the frequency of that class is F1. So the 10 minus 5. So D1 is 5. Next F2 is, so what is D2? D2 is FM minus F2. So FM is the frequency of the model class and F2 is frequency of the class which succeeds the model class. So this is F2. F2 is 4, F1 is 5 and FM is 10. So 10 minus 4 equal to 6. Now one more thing is there, I. What is I? Size of the class interval. In each class interval there should be a size. So 10 minus 0. 10 minus 0 is I equal to 10. Is it? the difference between the upper limit and the lower limit. So now we want to apply this old values L1. So L1 is, so L1 20 plus D1. D1 is 5 divided by D1 plus D2. 5 plus 6 into 10. Okay. So 20 plus 50 divided by 11. So the mode of this particular data is 24.545. So this is the equation for calculating the mode with class interval frequency data. So next measures of central tendency calculation is percentile. Percentile should not be confused with percentage. Percentage is used to express fraction of a whole, but the percentile are the values below which a certain percentage of data in a data set is found. So we can easily say that the percentage score reflects how well the student did on the exam. Okay, but the percentile score reflects how well he did in comparison to other students. So the percentile is for comparing with the other values in that particular data set. Otherwise, the percentage is only concentrating on how that student is performed in that class test or in that examination. Okay, so the calculation is, so like the calculation of the percentile is number of value below x by total number of values into 100. So like that the score, so this is one of the example with 10 student marks, 38, 47, 49, 58, 60, 65, 70, 79, 80, 92. Total 10 marks are there. So first we want to order in an increasing order only. If we want to calculate the percentile for 70, so first we want to calculate the number of values below 70, like 1, 2, 3, 4, 5, 6. Okay, so that is the first value 6. 6 divided by total number of values 10 into 100. Which one is that? 60 is the percentile for 70. Number of scores below 70 is 6. So 6 by 10 divided 6 by 10 into 100. 6 by 10 into 100 means 60 is the percentile for score 70. So the another value is if you want to calculate the percentile for 58. So below 58 how much values are there? 1, 2, 3, 4. Okay, so the 4 by 10 into 100, 40 is the percentile for the weight 48 in this example. Easy, but in an actual calculation, we are not calculating the percentile for particular data. We are calculating which data hold the 25th percentile or 50th percentile, etc. Okay, so for that there is another example. Calculate the pth percentile. If there is a 10 value data set, which data holds the 85th percentile? Like that we want to calculate for summarizing a data. So for that we are first arranging the data in an ascending order, smallest value to largest value. Then compute an index I. We are calculating an index. So we want to calculate 85th percentile. Our P equal to 85. So 85 divided by 100 into how many values are there in the data set? Let's assume that 10 values are there. 8.5. We are calculating an index value 8.5. So in this calculation we have got 8.5. 8.5 is I equal to 8.5 means it is not an integer. Then the step 3 containing two other variations. If it is not an integer, round up. We are rounding up to the greater value. If it is an 8.5 we are rounding to 9. If it is an 8.2 also, then also we are rounding up to 9. We are rounding to the higher value. Then that 9th value of that data set has the 85th percentile. If it is an integer, after that if we are doing this calculation and we have got I equal to 8, it is an integer, then we want to do like that 8th value plus 9th value divided by 2. I and I plus 1th value average. We are calculating I and I plus 1th value average. That is the calculation of the pth percentile. So let's assume that we want to calculate the 85th percentile of this data set. So first we are arranging the data in an increasing order. So it is already arranged. So the 85 divided by 100 into 12. This data set containing 12 numbers. So the value is 10.2. So the 10.2 is not an integer. So we are rounding up to 11. So which one is the 11th value? It is the 12th value. So it is the 11th value. 3730 is the value with 85th percentile. Clear? So 11th position value is with the 85th percentile. The quartile, the another important measures of central tendency is quartile. Quartile is very easy because it is easily calculated by all the previous central tendency measurements. It is often desirable in divide data into 4 parts. If it is a data set, we want to divide into 4 parts. So we want to calculate 3 points. 1, 2, 3 points. Division 3 points. So that we can easily divide the data set into 4 parts. So for that we are calculating 3 things, that is Q1 first quartile, that is nothing but 25th percentile. Q2 is second quartile, maybe it is 50th percentile, also median. If we are calculating the median or 50th percentile, we can get the same value. Then Q3 is third quartile, that is 75th percentile. So we are calculating this value, we will get 3 points, and according to this 3 points we can divide the whole data set into 4 correct parts. Okay, so let's do, see, like that we are doing with the quartiles. If it is a total data set, we are calculating Q1, that is 25th percentile, Q2, that is 50th percentile or median, or Q3. Then we can easily divide it. This is the first quartile, second quartile, third quartile and fourth quartile. So we can easily divide this first part, second part, third part and fourth part. Okay, so let's do with an example. See here, n equal to 12. So we want to calculate Q1, Q2 and Q3. Q1 is the 25th percentile. So 25 divided by 100 into 12. So this is 25 is 1 time. This is 4 times 4, 3. Is it? So 3 is the index we have calculated. So if we are getting the integer value, third position value plus 3 plus 1, fourth position value divided by 2. 1, 2, 3. That is 3450 plus 3480 divided by 2. So what is that? 3465 is the value of first quartile Q1. Q2 is 50th percentile or median also. If you are calculating the median, our n is equal to 12, that is even number. So our calculation is n by 2th observation and plus n by 2 plus 1th observation divided by 2. If you are calculating through median. So n by 2 is n is equal to 12. 6th observation plus 6 plus 1, 7th observation divided by 2. 1, 2, 3, 4, 5, 6. 3490 plus 3520 divided by 2. That we have already calculated, that is 3505, that is Q2. If we are calculating with the 50th percentile, so what is 50th percentile? 50 by 100 into 12. See, 1, 2, 6. So if it is a 6 value set, that is if ith value is an integer I equal to 6, we are calculating 6th plus 7th value divided by 2. Is it same? Is it? So we can easily get Q2. Then Q3 is 75th percentile. 75th percentile means 75 into 100 divided by 12. So this is 4, 3, 1, 3. So 9. We have got I equal to 9. If we are getting an integer value, 9th value plus 10th value divided by 2. Which one is 9th value? 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9th value and this is 10th value. 3550 plus 3650 divided by 2. Our Q3 is 3600. So we have got Q1, Q2 and Q3. Okay, so this is like that. This is the calculation. Q1 is 3465. Q2 is our 3505 and Q3 is 3600. So by using this 3 values, we can divide whole the data set into 4 parts. So the Q1 is 3465. So below 3465, 3 values are the. Then Q2 3505. So below 3500 and above 3465, 3 values are the. Here also Q3 is 3600. Below 3600, 3 values, that is above 3505. Okay, so like that we can easily divide this whole data set into 4 parts. That is our quartile concept. Clear? So that is all about our measures of central tendency, mean, median, mode, percentile and quartile. Hope it is clear now. Thank you for watching. Next video we are going with the descriptive numerical method, measures of variability. Thank you for watching.